Hello everyone. In this presentation I would like to talk to you about carbon dioxide emissions from cement factories. This is an important topic, as about 5 to 7% of the total human-made carbon dioxide in the atmosphere comes from cement production. Cement is actually a cohesive factor that is used in conjunction with other building materials to make what we know of as concrete. So it is not the drying or the mixing of concrete that emits carbon dioxide. It's the actual process by which cement is manufactured. This process begins with the extraction of rocks and minerals, primarily calcium carbonate, which we commonly know of as limestone. Other materials include magnesium carbonate, silica, alumina, and iron oxide. These rocks are then taken to a factory, where they are crushed, ground, and mixed into a powdered material that eventually enters into a kiln. Inside this kiln, the powder is heated to about 1300 degrees Celsius, forming a molten substance called clinker. Inside the kiln is also where all the chemical reactions occur. After these reactions are completed, the clinker is cooled down to about 100 degrees by a fanning system. This forms a hard material that once again needs to be crushed and ground to form cement. So where in this process does all the carbon dioxide come from? Well, about 50% comes from the actual chemical reactions that happen inside the kiln. Another 45% comes from the energy that is required to heat the kiln as well as cool the clinker. From a chemistry perspective, these are the two most important reactions in producing carbon dioxide. At about 550 degrees Celsius, calcium carbonate and magnesium carbonate dissociate into their respective monoxides and carbon dioxide. Two calcium monoxides then bind with silica at about 900 degrees to form dicalcium silicate. The dicalcium silicate then binds with another calcium monoxide at about 1200 degrees to form tricalcium silicate. This is extremely important, as for every one tricalcium silicate formed, 3 carbon dioxide molecules are required to be emitted from the factory and into the atmosphere. Tricalcium silicate is also the primary component of cement. As you can see from this table, 45 to 60% of cement is tricalcium silicate, which requires 3 carbon dioxide molecules, while 15 to 30% is dicalcium silicate, which only requires 2 carbon dioxide molecules. Thus, when scientists talk about reducing emissions from chemistry, they often talk about reducing the ratio of tricalcium silicate to dicalcium silicate. But this is hard to do, as the reactions are difficult to control at high temperatures. Another material scientists are excited about is calcium sulfoaluminate, which is similar, but requires less heat, less calcium carbonate, can use the same equipment, and is said to reduce emissions by about 40%. But this is only half of the problem. Another 40% of the emissions come from the burning of fossil fuels that are required to heat the kiln to 1300 degrees. And 5% of the emissions come from the electricity that is used to run the fanning systems. So there are 3 ways in which factories can set up production. These are classified as wet, semi-wet, and dry production processes. How they differ is in the amount of energy required to remove water content that exists in the powder entering the kiln. The wet cement process is the same as in the introduction. In this case, the powder contains about 30 to 40% moisture. This means that the kiln is going to have to expend extra energy to get rid of the water content. In the semi-wet process, an extensive set of pipes or auxiliary equipment is required to take hot steam from inside the kiln and expose the powder to that hot steam. This dries out the powder and reduces its moisture content to about 10 to 20%. In a dry cement process, further auxiliary equipment called a calciner is required. The calciner is like an oven and removes all the moisture content from the powder. This is said to reduce emissions by up to 20% and energy costs by 50%. So why don't all the companies use dry cement production? Well, like many other industries, change is slow, and companies might not yet see the economical or environmental benefits of the dry cement production process. So finally, this graph puts into perspective how much carbon dioxide has been emitted due to cement production. From 1990 to 2006, the total carbon dioxide has increased from 576 million to 1.88 billion tons, while it is projected by 2050 that we will have emitted 2.34 billion tons from cement production. This makes it evident that we should start to consider other building materials and processes to reduce our carbon footprint in the future. Thanks for tuning in.